Hey everyone, welcome to Physics Parikrama. Hope you all are doing good. So this lecture 2 on work per energy, and I will solve and explain previous year Neet problems upon it. So let's get started. So read the question. A disc of radius 2 meter and mass 100 kg rolls on a horizontal floor. Its center of mass has speed of 20 semi per second. How much work needed to stop it? So first visualize this problem. This is the disc, okay, and this is rolling like this, and its center of mass, which is situated at here, is moving with speed 10 semi per second, and its mass is equals to 100 kg. So what work has to be done to stop it? Now see, the total energy of this system, if we find, then if I give that amount of work to this system, then it will be stopped. So we have to find out the total energy of this system. Now as this disc is rolling, so it have two types of kinetic energy. One is translational kinetic energy, which is equals to half mv square, and another one is rotational kinetic energy. As this disc is not slipping, this is rotating, so this is rotational kinetic energy, and it equals to half I omega square, where I is equals to the moment of inertia of this system and omega is equals to the angular velocity. Okay, now what is the moment of inertia of that system with respect to this axis? Now as this disc is rolling in that direction, so the disc is basically rotating about this axis, passing through its center of mass. So we know the moment of inertia about this axis of a disc, that is half m r square. Okay, so put it here, half into half m r square into omega square. We know V is equals to r omega, where r is the radius of the disc. Okay, so V is equals to r omega, put it here, 1 by 4 mv square. So the total energy of the system is equals to half mv square plus 1 by 4 mv square. So it becomes 3 by 4 mv square. So put the values, 3 by 4 into 100 into v square, that is 400 into 10 to the power minus 4, as this was in semi per second. So the answer is 3 joule. So that much work has to be done to the system to be stopped. So option 1 is correct. So first read the question. A piece of ice falls from a height h so that it can melt completely. Only 1/4 of the heat produced is absorbed by the ice, and all energy of the ice gets converted into heat during its fall. Value of h is what? Given that latent heat of ice is equals to 3.4 into 10 to the power 4 joules per kg, and G is equals to 10 newtons per kg. So let's solve it. So first visualize this problem. A ice, let's say of mass m, is at a height h. Okay, and we have said that the all energy of the ice gets converted into heat during its fall. So the energy at that point, I mean let's say this is point A, is mgh. Energy of point at point A equals to mgh. Okay, now the whole energy is converted into heat, so the heat is equals to mgh. The whole energy is converted into heat. Now we have said that if only 1/4 of the heat produced is absorbed by the ice, so 1/4 of the heat is enough for melt the ice. ठीक है. So the heat required to melt the ice is equals to m into L. L is the latent heat. So let's put the values. mgh is equals to ml. So mm cancels out both side, and h is equals to 4 into value of L is equals to 3.4 into 10 to the power 4 by 10. So it becomes 136 into 10 to the power 3 meter. So option 3 is correct. So read the question first. A body of mass m begins to move under the action of a force F vector is equals to 2t I cap plus 3t square j cap Newton, where I cap and j cap is the unit vector along x and y axis. Then calculate the power, where here given that m is equals to 1 kg. So let's start. F vector is equals to 2t I cap plus 3t square j cap. We know force is equals to mass into acceleration. So we have said that mass is equals to 1 kg. So acceleration is equals to 2t I cap plus 3t square j cap. Now we know acceleration is equals to dv vector by dt. So 2t I cap plus 3t square j cap, where v vector is equals to the velocity. Now dv vector is equals to 2t dt I cap plus 3t square dt j cap. So integrate both sides with respect to t. Then we will have v vector is equals to t square I cap plus t cube j cap plus integration constant c. Now in our question it is said that a body of mass begins to move. That means at t is equals to 0, the body is at rest. That means its speed at t is equals to 0 is equals to 0. Hence we can say c is equals to 0 from this equation. So we have v vector is equals to t square I cap plus t cube j cap. Now here we have to find out the power. So power is equals to, we know the relation F dot B. Hence 2t I cap plus 3t square j cap dot product t square I cap plus t cube j cap. So we have 2t cube plus 3t to the power 4. So what is the option? So option 3 is correct. So let's read the question. A force F is equals to 20 plus 10y acts on a particle in y direction, where F is in Newton and y is in meter. Work done by this force to move the particle from y is equals to 0 to y is equals to 1 meter is what? So let's solve. This is x axis, this is y axis, and the body is in that direction or in that direction. Okay, now a force is acting in y direction. Okay, we have said that, and the body is moving in y direction. The body moves dy amount of distance along y direction, and the whole process, in this whole process, the work done on the body is dw. So we can write dw is equals to F into dy, force into displacement. So force is equals to, we have 20 plus 10y, 20 plus 10y to dy. Now integrate with respect to y. So we have w is equals to 20y plus 10y square by 2. We have limit of y, that is y is equals to 0 to 1. So y is equals to 0 to 1. So put the limits. So work done is equals to 20y plus 5y square, where we have the lower limit 0 and the upper limit is 1. So 20 plus 5 minus 0, so 25 joule. So option 3 is correct. Hey all, that's it for today. In next lecture, we will solve more problems on that topic. Till then, please stay tuned. Hope you like. If you are new to my channel, then please do subscribe Physics Parikrama. See you soon and bye bye.